Regrettably, we must close the school. But Mrs. Angus, my year 12s, they need me.
Now, look here, old chap. I'm Boris, and if I say shut the schools, I mean shut the schools.
No!
You use chemistry as your life unfolds. You need chemistry to understand the world. But when we're faced with long distance learning, then I use my camera to teach you chemistry.
How to teach them periodicity. I know. I'll use my chemistry powers to travel the periodic table and show them trends, especially as you go across period 3. Come to me, magic cloud. Fly, magic cloud.
Find me a periodic table, Cloud. No, not that sort of periodic table, you stupid Cloud. We're not going for dinner. This is serious. My students need me. Now look here, Cloud. These people might look serious, but it's the wrong sort of tables. I need a periodic table. Periodic, get it? That looks a bit more like it. Well done, Cloud.
Right then, you lot. You've done this before. Write out the electronic configuration of these. The first one is 1s2, 2s2. Now, no peeking. Pause the video. The answers. Now, don't forget, 4s gets filled up before 3d, but they then get removed before the 3d when forming ions.
Our focus is on period 3 only. This is them. Now you need to know the trends in atomic radii, first ionization energy, electronegativity, and melting and boiling point, all as you go across the period. You there, tell me what you think will happen to the size of the atoms as you go across the period. Bear in mind that they've got more protons, more neutrons and more electrons as you go across. What do you think? Will they get bigger? Will they get smaller?
I guess they'll get bigger then.
Wrong!
As you go across, the electrons enter the same shell, so there's no change there, but the nucleus gets more positive as you cross the period, so the electron shells are pulled in more strongly. The atoms therefore get smaller as you cross the group. Right, page 147. Read it and explain how the atomic radii changes across period 3, and for good measure, how it changes going down a group. Next, it's first ionization energy. Again, this should sound familiar. It's the energy needed to remove a mole of electrons from a mole of gaseous atoms. So how's that going to change across period 3 then? Eh?
Pause the video and have a think. I'll give you a clue. There's a trend either that way or that way.
As you go across the group, the electron you're going to remove is in the same shell, so it's the same shielding and it's the same distance from the nucleus. However, the nucleus is more positive, so the electron is more difficult to remove. There's a general increase in energy needed to remove the electron. There are two little bumps, which we covered a while ago. The bumps are to do with the 288 model not being quite right and the new model which involves s and p orbitals. Time for some more work from you.
Now then, you at the back, please explain why there's a dip from magnesium to aluminium.
The outer electron is in the 3p orbital, which is a higher energy level than the 3s. It is both further and more shielded from the nucleus, so easier to remove.
Very, very good, you at the back. Now you down there at the front, can you tell me why there's a dip from phosphorus to sulfur? Phosphorus to sulfur.
In the 3p orbital, there are two paired electrons. The repulsion between them means that they are at a slightly higher energy level, so easier to remove.
Very good, very good. Perhaps start of the class, well done.
Thank you.
Recently you saw that fluorine is the most electronegative element. So it's safe to say that electronegativity increases from left to right. Pause the video, see if you can explain why electronegativity increases left to right.
Okay, here are your answers. Increased nuclear charge, but same number of shells.
Let's move on to our final trend, melting and boiling points. Actually, this question is about bonding more than anything else. If we can understand the bonding, we can understand the change in melting points as you go across the period.
Pause the video and see if you can match the bonding with the period 3 element. Okay, let's see how well you did.
So now we know what the bonding is like in each of the period 3 elements. What I would like you to try and do is rank the melting and boiling points from highest to lowest. Which one of period 3 has the highest melting point or boiling point, and which one has the lowest melting and boiling points. Remember, for a substance to melt, you need to overcome whatever bonds there are between the molecules.
Pause the video and rank from lowest to highest boiling point.
Now, could somebody out there talk us through the results, please? Very stick together. Oh, so you're putting that one up there?
Seems to be two. Okay, wait. Why is this okay?
You help each other out so don't
What does
just use
lupus
yours.
mean?
They're negative.
What does that mean?
And there's positives.
I think
Do
I feel like I've got
positives-
the hardest
Oh,
one.
um,
Do positives and negatives, do they attract each other?
I don't think so.
Yeah, they do, because opposites
Well then,
attract.
let's go there.
um,
No, there probably. I don't think we'll. So why don't you just do the top of it?
Okay.
Because they're very.
Violet, do you know what the
twos and threes mean? Do you think?
They look.
I've got all the
How's
hard
it look?
ones. That's not fair.
Very easy.
Violet, let's.
Which ones look more stuck together?
We can
I
change
think
them.
that one's harder. Go there.
Really?
Yeah. No, why are you doing it so
You see,
little?
they're quite small, though, aren't they? They're
Yeah.
not a lot bigger than those ones, there, really.
Oh, so put that down now. These are tiny.
Yeah, actually, which is smaller, those ones?
That one.
Okay.
I don't know what.
That's
We'll
alright.
just stick these
Okay,
on
so
randomly,
Which way?
okay?
No, there's an order. Which way do you
Okay,
think
so
you're going to go?
free.
Right,
Let's do
opposites
free.
attract, so which is going to stick together most?
The free and the two.
Give me some.
Okay, go on then. So there would go,
When it's some-
That one goes
go Violet.
there.
Okay, good. Yeah, thanks.
Because of the highest number. And then this one doesn't have a number.
So that's just base 1.
Oh, okay. Well, that'll do.
Okay, thank you very much, volunteers.
Let's see how well they did. Starting with the metals. High melting and boiling points that rise due to the increase in charge on the ion, aluminium is 3+, and the increase in the number of delocalized electrons. Next, the the element in period 3 with the highest melting and boiling point, due to its giant covalent structure, it's silicon. After this, we have 3 elements with simple covalent structures, and therefore low melting points. Chlorine molecules are the smallest, so it has the lowest boiling and melting point. Finally, the monatomic noble gas argon, which has the lowest melting and boiling points of the period. Now, for your work, pause the video and use your textbook to answer these questions. And now, the answers. What the hell? Where am I? I feel like I've been trapped in this house forever. Just one word going round in my head, over and over and over again.
Periodicity. 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 Periodicity.